Hi guys, welcome back to our channel Think in Code. Today we are going to discuss about typecasting in C++. Typecasting basically available in C, but it's not necessary. In C++, the future called strictly type checking. So we have to do some typecasting. For that we have different methods. So in this video we are going to discuss methods and uses along with its disadvantages. Yeah, what we are going to learn in this video: what is typecasting, types in typecasting, what is implicit typecasting, what is explicit typecasting, drawbacks in typecasting. The most one is, what is typecasting? Typecasting is a mechanism to converting one data type to another data type. It is, for example, integer to double, double to float, float to character, whatever it may be, anything. The second one is typecasting, its types: implicit typecasting and explicit typecasting, both. The most one, implicit typecasting, it is automatically done by compiler. It's converting one data type to another data type without program evaluation and involvement. We are going to see some examples in this. Here we are seeing the first example, that is, yeah, here we are seeing first example. Here I declaring a integer variable a and assign with the value 10, and I will store this variable with a double variable and assign with integer variable a. Here we doesn't mention any type externally, but internally compiler will be automatically done its typecasting. And here we store the a value into b value. The result we will check. First we compile, save, and compile it. Compilation is successfully completed. Then we go for execution. Here execution, it will be give. I think it's 10. Exactly 10 will be came here. And one more example here. Here the example 2. Here we check example 2. This is the example 2. Here we assign a character variable with data capital A. Actually, we have an ASCII values. It is a ASCII value is 65, that will be stored into integer variable without any external typecasting. Here we check what will be the result. Here first we save and then we compile it. Yeah, compilation is successfully without any errors. Final execution. Maybe it's giving 65. Absolutely correct. It's giving the 65. We are going the third example. One more example. Here we need to check it's a multiplication or summation, anything. Here we are declaring the two integer variables a and b and assign with 5 and 2 respectively. We are storing the sum of a and b into the result. It's in a double data type. Here, without we are mention any typecasting externally, but internally compiler will be done integer to double. It will be giving and store the result in result variable. Here, first we save this code and compile it. Yeah, maybe without any errors, it will be done successfully. Yeah, absolutely. It will complete compilation and we do execution. Absolutely, it will give whatever the 7 it will be give, maybe. Yeah, exactly 7 will be came. That's it. It's about the implicit typecasting. Yeah, the second one is explicit typecasting. Here, uh, externally, the programmer involved which type it is converting without compilation involvement. Here, several types of explicit typecasting here. Here, most is several five. One is C style and static casting and dynamic casting, constant casting, reinterpret casting. C style. It is the one of the typecasting type. Here we seeing this some example in this. Here, yeah. Here, the first example we see, I already done the program, just showing your purpose only. I will show it here. Yeah. Here and I declare an variable integer variable a and assign with the data 10 and one more variable double, it is b. I will explicitly inform it double, it convert the a data type. Basically a is an integer data type. It explicitly I will mention it is a double. It will be store the data into double. So the result we will see. First we say unquit. Sorry, here first we save and okay. Here we compile it. Yeah, compilation is successfully completed. Zero errors, zero warnings, and we say execution. Yeah, exactly 10. What I expect is correctly, absolutely correct. And we see one more example. See one more example. I already done with the examples and showing we. Yeah, here two integer variables a and b, and a will be assigned with 5 and b will assigned with 2. The result we will here I will show some magic on this. Here double will be result a variable. It is a double data type. Here explicitly not, I'm not inform anything, but here a modulated by b, the result I, as we guess it is 2.4, but we see what it will give. First save, then we compile it. Yeah, compilation is successfully done. Then we check the result. It's give maybe I think two. Yeah, exactly, I am correct with that. Once again I will show this magic, but here we doesn't mention anything here. If we mention any one of the variable as a double explicitly, what will be going and what will be giving? We are checking it. Yeah, sorry for inter double. Yeah, it's done. Here, if you expect its a result is 2.5, yeah, it will giving output whatever it's. We check. First if save and quit, then it will compile. Yeah, compilation done with zero errors and zero warnings. Yeah, it's a time for checking the result. Yeah, exactly 2.5. It's like exactly. Yeah, let us we are seeing the third example in this problems. Yeah, we already I provided the program with here we have one integer variable x and assigned with the data 100 and one character pointer p, and will be trying to I'm trying to here giving the address of integer variable to character pointer without any external typecasting. We are seeing the what is the output we are getting. Yeah, basically is in C++ we having try strictly type checking as we know before we setting this. Yeah, why we here we check what is the output. Yeah, first we compile. Sub compilation is error. Why? Because this error we getting. I already said to you is C++ having this strictly type checking, so it will be definitely we mention externally which type of we converting. Here we converting the character pointer to character, the integer variable we trying to convert it into character type, so it will be correct form. Maybe it will be giving the answer in, it will be pointing to the last one byte data of the x variable, and it will be 100. The 100 in the sense small d we know as keys. So we are trying to under compilation. Yeah, compilation is done with the zero errors and zero one x. Now we see it is a execution time. Yeah, exactly is a D. It's correctly. And we see one more example in this same example. Here, yeah, yeah. Here we are assign one character variable with the data 20 and one more character integer pointer cap p, and we are trying to you're trying to externally mention as an integer data. Actually, integer a character having the only 1 byte data, but we are trying to assign the 4 bytes data. A remaining 3 bits, 3 bytes we are giving the important data with other variable or garbage data, whatever it may be. It doesn't expect anything. So what we will giving, we are seeing this example. So I think as of my, it will giving the garbage data. Yeah, compilation is done with zero errors, zero warnings, and it is a execution time. Uh, yeah, it's a giving the garbage data. Exactly. Why? Because why? Because here, why? We have one more example on the same topic. We go into examples with the class and object types. So here, open the program. Yeah. Here we see one base class and one more. The base class is derived with the derived version. Here we in this main function we are declare one object that is derived version object D. Okay, we are trying to this base class pointer through we will pointing to the derived version, but it will be typecasting with the base version. Here the problem is upcasting. It will be absolutely wrong. Why? Because we are trying to base class pointer through we derived with the same type derived version. It is the problem of casting. Yeah, we see one more examples in same topic. Yeah, see, we already done with program, but you see, we have one more. This in this example, we have base class pointer. This base class pointer we derived with the derived class. Yeah, here we see we are creating one base class pointer D B and we are pointing to the base class. It's absolutely fine. And here derived pointer will be pointing to the derived upcasting through base class pointer. It is a downcasting. Here in the sense it is a derived in the small than the base class pointer. But we are trying to pointing to the higher class. What is in base? It is absolutely wrong. A downcast with downcasting error, but it is not giving the error. It is also compiling and compile. Fine. Here see compilation. Yeah, compilation is done. Why? Because Because it is done by why we avoid these problems means it will doesn't expect it is giving the undefined behavior. So that purpose we are avoiding. So and it is a one scenario and commented this scenario and we will see second scenario in same problem. Here the second scenario we base class pointer through we are pointing to the derived version, but here derived version pointer will be pointing to the derived version with with external typecasting. So it is doesn't mention any errors, any warnings. It is absolutely fine. It is a good approach to practice coding. Here we say yeah, it will be giving error. Why? Because will be pointing to the derived version. But here we derived pointer is it will be trying to externally function derived. Yeah, it's absolutely fine here. It is the safest thing in this entire class and object oriented typecasting programs. Here we see it's compile. Yeah, zero errors and zero warnings. Absolutely.